Yeah, number one, we had to take this one and write it with a positive angle. So let's review just really quickly here about negative angles here and about which functions are even and odd. So our even functions, our even trig functions here are cosine and secant, and then the other four are the odd functions. And now our odd functions here would be sine and cosecant and cotangent and tangent. So it's all about the negative sign. If it's even, and the negative sign doesn't matter, we just throw it away. But if it's odd, we're basically going to pull it to the front and make it negative. Now this one's cosine, so the negative can just go away here. So this would just be the cosine of 20 degrees. Notice the directions say to not evaluate. So that's my answer. Okay, number two, we got the sine of negative pi over 12. So now, since sine is odd, we're going to pull that negative to the front. So this would just be the negative sine of pi over 12. Okay, number three, we've got secant of negative 300. Now remember, secant is even, so this would just be secant of 300. Number four, if cosecant of negative 7 pi over 8, so we're going to pull that negative to the front since cosecant is odd. Number five, we got tangent. Remember, tangent is also odd, so we're just going to pull that negative to the front here. Now, number six, we got cotangent. Remember, cotangent is also odd, so we just pull the negative to the front. Okay, now on number seven, we're going to evaluate this. And so I do need my unit circle here, so be sure you have your unit circle in front of you. You'll get a blank one on the test to kind of fill out to help you with these particular problems here. Now, instead of negative pi over 4, what we're going to do is we're going to pull that negative to the front and just find the cotangent of pi over 4 and just take the opposite of that. So I'll bring my negative down, and I'm going to sketch this out for you. At pi over 4, your ordered pairs, they're square root of 2 over 2 and square root of 2 over 2. Now remember that cotangent is cosine over sine. So we put this one over this one. They're just going to cancel each other out because they're the same thing, and so that would just be 1. So the cotangent of pi over 4 is just 1. Now when we take the opposite of that, my answer is going to end up being negative 1 there. Now number 8, we're looking at the cosecant of negative 7 pi over 6. Now again, let's get rid of the negative sign. So since cosecant is even, we will pull it to the front. We have the negative cosecant of 7 pi over 6. Now, let's see where 7 pi over 6 is on my unit circle. We're down here in the third quadrant. So my ordered pairs here, I've got negative square root of 3 over 2, and then negative 1/2. Now recall, cosecant is the reciprocal of sine. So we'll take the reciprocal of sine. Now let's break down this negative. And then the reciprocal of negative 1/2 would be negative 2. So we've got the opposite of negative 2. So that's just going to be positive 2. Now number 9, we'll find the cosine of 5 pi over 6. So we got 5 pi over 6 is about right there. And then our ordered pairs are negative square root of 3 over 2 and 1/2. Now with cosine here, since cosine is even, we can just totally disregard the negative here. So this is just the cosine of 5 pi over 6. The cosine is the x-coordinate here, so that's just going to be negative square root of 3 over 2. Okay, now number 10, we have to simplify this. So we're going to use our strategies here of changing everything to cosine, sine and cosine, our Pythagorean identities. Let's see what else. Our reciprocal identities, which is changing everything to sine and cosine, finding a common denominator, and factoring here. So let's notice here that first off, 1 over cotangent squared. Now probably you could change that to everything to sine and cosine here, but I'm going to use a reciprocal identity. 1 over cotangent squared would just be tangent squared. So that would be probably the easiest thing to do right there. Now, to clean this up, because these are reciprocals, I'm going to change those to sine and cosine. So that would be cotangent x would be cosine x over sine x. And then tangent x would be sine x over cosine x. So those are all canceled there and just give me 1. And so I've got tangent squared. So, if you changed everything to sine and cosine here, you probably realize that wasn't really going to get you anywhere. So it's better to leave that as tangent squared. This way, now I have my Pythagorean identity. So I'm going to use my Pythagorean identity here that tangent squared plus 1 is equal to secant squared. Now number 11, we've got secant over cosecant. So notice no squares, no 1s. Let's change everything to sine and cosine here. So secant is 1 over cosine, and cosecant is 1 over sine. So now we've got a complex one here. So since it's complex, we're going to multiply by the reciprocal. So we'll say 1 over cosine x times the reciprocal of 1 over sine x would just be sine x, or sine x over 1. So we get sine x over cosine x, which is tangent x. Number 12, let's start off. I'm going to use a reciprocal identity to start off with. Instead of changing, when you get 1 over cosecant squared, or 1 over tangent squared, or 1 over cotangent squared, or 1 over secant squared, instead of changing everything to sine and cosine, certainly your reciprocal identities work a lot better in this case. So let's notice what we get here. When we do 1 over cosecant, where cosecant is the reciprocal of sine. So this would just be sine squared. Now if you change everything to sine and cosine, you'd still get sine squared right there for that. So shorter way to simplify that. Now over here, cosine times cosine would be cosine squared. And so that's our Pythagorean identity there. Sine squared plus cosine squared is 1. Now number 13, we've got a lot of multiplication, so I'm going to try to change everything to sine and cosine here. So tangent would be sine x over cosine x. We've got times cosine x all over, and then cosecant would be 1 over sine. So this is kind of complex. Let's kind of clean it up here. So cosine x cancel. So now this leaves me with sine x over 1 over sine x. Okay, now let's multiply by the reciprocal here. So this would be sine x times the reciprocal of 1 over sine x would just be sine x. You can say sine x over 1. But this is going to give me now sine squared x. Okay, number 14, just simple multiplication, so probably changing everything to sine and cosine here. So we can do cosine x over sine x times secant here would be 1 over cosine x. Now cosine x's would cancel, so this leaves me with 1 over sine x. And by my reciprocal identity here, 1 over sine is cosecant. Now number 15, notice it's just a simple division. So remember, we could change division to multiplication by multiplying by the reciprocal. So that means I want to change everything to sine and cosine again here. So we'll go cosine x over sine x, which is cotangent x, over 1 over sine x here. Okay, now again, I've got another complex ones. I tried to load the review here with complex ones. I thought we probably needed extra practice there. You kind of tell that there's a lot of them. Now, we're going to multiply by the reciprocal. So the reciprocal of 1 over sine here would just be sine over 1. So those would cancel. So we'll just get cosine x.
I think the student placing your attention.
Okay, on number 16, we have the spot here that we see cosine squared twice, so that should tell me here that I need to factor. So we're going to factor out a cosine squared. Now, let's notice we got a Pythagorean identity right here. So 1 plus cotangent squared would be cosecant squared. So I'm going to have cosine squared times cosecant squared. Now, since we're multiplying, let's change cosecant squared into 1 over sine squared. Okay, now you can see this is going to give me cosine squared over sine squared, which would be cotangent squared. Okay, on number 17, very similar problem here. Again, I'm just going to factor out a cotangent squared. So this is going to leave me with 1 minus secant squared. Now, 1 minus secant squared would be Pythagorean identity. So let's look at this one. This one's not that straightforward here. So my Pythagorean identity, I know that tangent squared plus 1 equals secant squared. So to get 1 minus secant squared here, I would take it and move it over, okay? And then therefore I would have to switch tangent squared over here. So they're basically switching. So both of these are negative. So we get 1 minus secant squared equals negative tangent squared. So 1 minus secant squared is negative tangent squared. So now that's going to give me cotangent squared times negative tangent squared. Okay, now since we're multiplying, let's change them both to just terms of sine and cosine. So this will be cosine squared over sine squared times negative sine squared. I don't know where theta came from. Sine squared over cosine squared here. Now, notice almost everything cancels out, but recall this was negative here, so the negative is just going to be left behind, so this is negative 1. Okay, I'm going to stop at 7.